Okay, guys, the coordinate system, Kevin, you need to sit someplace else. The coordinate system that we've always used is the XY plane. And when you get into college, you're going to find there's other ways of graphing and locating points. This is called the Descartes. Descartes is the one who came up with it. It's called the Cartesian coordinate plane. So the first thing we have to do is when we're going to change our coordinate system into a polar coordinate system, and it's going to look different. Well, some things will look the same. And we have to be able to convert back and forth between Cartesian and polars. Excuse me. Take it. Okay. Now, when you look at polar coordinates, you're going to find this coordinate based on how far it is from the origin, it's called the radius, and the angle this ray makes with the axis. So the ordered pair is how far from the origin and what's the angle from the x-axis.
But this just all like this trig. Yeah.
We're going to have some trig involved in here.
Some or a lot.
It's going to be a lot. Okay? Now, why would I do this? If I'm a pilot in a plane, I'm not going to give my coordinates as x and y.
That's where we're going to drop the bombs, you say.
I'm going to give my coordinates. I'm coming in 20 miles. I'm southwest of the tower. Okay, so you're given how far you are from the tower and the angle at which you're approaching. And that would be another dimension because you have to worry about your altitude as well. And I believe those are called spherical coordinates. There's cylindrical and there's spherical.
Yeah.
Okay? Yeah, you might know this. Okay, so what we're going to do is we're going to work with the polars today. We're going to convert, and you're going to have to be able to graph this. This right here, actually I think I have it on my handout. Oops, let's go back. Okay, these are the things we're going to do. We're going to express x and y in terms of an angle and a radius. Sam? Write the functions in polar form using radius and angle. Graph some simple polar functions. There will be some polar problems on the multiple choice without a calculator. So you're going to have to be able to graph the simple ones. Find tangents to curves, to polar curves, finding where these intersect. That is tomorrow, and then we're going to be working on AP problems.
After this week, how far for the AP exam?
We have one chapter left after this spring break.
No, I'm just wondering, if I take the practice test, there's like a bunch of stuff I don't know.
There won't be a bunch you won't know. There'll be a little bit, not much.
And what is it?
Chapter 7.
What is chapter 7?
Chapter 7 is differential equations. Yeah, Euler's method and logistic curves, slope fields. But you'll see when we get all that. I'm going to pull it all together for you. And we'll be reviewing Taylor polynomials. Okay. They're not that hard. Okay, you guys, this is called the polar axis. We always measure relative to the polar axis. This can be a little bit confusing because we can have other ways of talking about ordered pair. There's two ways to label an ordered pair here. This radius, as long as you're going this direction, is going to be r, and my angle, or my ordered pair is going to be r theta. And r is the distance from the origin to the value. What if r is negative?
Can it be?
Yes. It's going to go the opposite direction. If r is going this direction, a negative r will go this direction.
Theta is the same though, right?
Theta is the same. But could you get theta? You can get theta this way, but could you also get theta going around that way? Yes. So there's an infinite number of ways to represent that particular point.
Would you ever have it listed instead of r theta as theta r?
No, it's always r theta, just like xy. Okay, so we would like to graph some points. And there they are. So you guys can try it as I do this. There we go. And I used to have nice graph paper, but I don't. You're going to have to create a graph, just like I'm going to. Yeah, I suppose I could have put a graph in there. And so the radius on number 1 is 1, and the angle is 5 pi over 4. Now you guys remember how to do the pi's, right? The easy way?
Multiply by 180.
No, easier.
It's the bottom left, right?
Oh, you guys don't know the easy way.
All students take calc.
No. It's 5 times, no, forget the unit circle. It's 5 times pi over 4, but that's 45 degrees, right?
Yeah.
So I'm just going to count over 5 of them.
Yeah. Awesome.
1, 2, 3, 4, 5. So it's this angle, and I'm going to go a distance of 1 unit. So we'll call that 1 unit.
I do that. But is this all the same?
Pardon?
Yeah, is this as tough as forward?
No.
I was gonna say. Is that like
Okay, so where is 2 and 3 pi? So you're going to go,
It's gonna be at 180 degrees.
here's pi, there's 2 pi, and then there's 3 pi, and I'm going to be twice as far away from the origin as that, so maybe it's over here.
Why couldn't they just say pi?
They could have. That's why I said there's an infinite number of ways to write one of these ordered pairs.
There's so many things they do that could be done this year. They just make it work.
Wait, we're gonna make functions out of this? It's like
Oh, just wait. Okay, how about the next one? 2 and negative 2 pi over 3. Maybe we should do a new grid, because now we're going to do pi over 3. Right, but I got to get the pi over 3. How many degrees is pi over 3? 60. So I'm going to put in my little dotted lines. So it's 60 degrees. And then I have another 60 degrees here. That's not quite right. Oh, maybe it's okay.
It works.
No, I don't like that. It's going to be me fixing this. And then this one's going to be up here a little bit.
There you go.
That's better. Not good, but better. These should be congruent. Why? How big should each of these be?
60.
If this is 60, how much should each of those be? That'd be 30. Okay, so I want to go negative 2 times pi over 3. So I want to go backwards. So there's 1, and there's 2, and my length is a positive, so it still goes in that direction. If that had been a negative 2, I would have gone in the other direction. So first I do the angle, and then I do the radius.
What does the negative mean?
The negative means it goes opposite direction.
Oh, okay.
As opposite direction as
But the point
What?
doesn't have that.
You have to follow this angle. You stay right on the angle. If this had been a negative 2 pi over 3, I would have gone over this angle. Positive 2 goes this way, so negative 2 would
so
go.
never negative is always
that way.
the axis.
No, not necessarily.
Oh, but always starts.
You always find your angle. You always find your angles. Then this would be up here.
That just seems.
That'd be negative.
So that green one is too negative. Negative.
That's negative 2 pi over
It's on
3.
the opposite side of what it's already on.
You find the ray for the angle. Here's the angle, and I would go 2 on that angle, but if this is negative, I go the opposite direction. Let's do the next one, because that'll be similar to that. Was that? No. That's crooked. Yeah, that would drive me nuts. Okay. Okay, we're going to put in, now this is pi over 4. So these are 45-degree angles. Okay, so now I go through the angle. I'm going to go 3. It's positive, right? 1, 2, 3. Now, if this had been a positive 3, I would have gone out this way. But it's not. Guys, out the door then. This is not time for this. This is what? Negative 3. So where's it going to be?
Down.
Down. 1, 2, 3.
So that's where it is.
Yes. And it can get confusing because as we're going to be plotting some of these polar curves, it can be confusing.
So as an FRQ on that,
These are points right now.
as an FRQ on that, would you have to show the line?
No. You would just draw it. No, this is not going to be that simple for the
Well,
FRQs.
so you'd have to make it longer.
Oh, no, dude.
The one that is more.
You're going to have this inning this easy of it.
So if you write that as 3 hours,
Yeah, how else could we write this? I could also, is this point right?
so 3 is
one negative.
You could do 3 comma what? Negative pi over 4. And then you could keep adding 2 pi's to these. So there's an infinite number of ways to write each of these points. Okay. Are we ready? That's just how you plot points.
I feel like 4 is a smart calculus.
We'll do the calculus here.
Rip it.
Oh. I can make that a little bit bigger. Maybe. Okay, and this is really important, this part right now. I'm going to slide this down. Now consider this diagram, find x and y in terms of the angle. I'm going to highlight the things you have to know in the exam. This is one of them. And we'll call this angle theta. The tangent of theta is what? Y over x. And so if you wanted to find the angle, it's the inverse tangent of y over x. But I want to find out what x and y are, too. So I'm going to use some trigonometry. What is the sine of theta, looking at my picture?
Y over R.
Y over r. Or y is equal to r times the sine of theta. This is old, yeah, this is old trig, right? And the cosine of theta equals x over r, or x equals r cosine theta. I'm going to use one of my special pens because this is what you have to know. When you get into a polar problem, that's what you're going to have to know. Remember,
Is that kind of self?
no, because when you see the problems, you'll see.
Just think about it. Yeah,
Right. And this is equal to the slope. Well, we'll do some problems. You're going to find them a little bit challenging. Okay. So I want to convert 2 and pi thirds to Cartesian coordinates. I think it's easier to go that direction. So r is equal to 2. Oh, what else did I have to do here? What's true about x squared plus y squared? Forgot that one. Put it, x squared plus y squared equals r squared. And theta is equal to pi over 3. Okay, those are the relationships that are not hard, but that's what you want to keep in the back of your mind when you're doing some of these problems. Okay, so I want to find x and y. So x is equal to r cosine theta. So x is equal to 2 times the cosine of pi over 3. And Justin, what's the cosine of pi over 3? Yeah, well, we have to know this. Well, you know what I do? Because I never remember either. Here's a 60-degree angle, here's 30. Okay, pi over 3 is 60, so it's 1/2. Yes. Okay, what's y? No. This is just the beginning. R sine theta. So y is equal to 2 times the sine of pi over 3. I have my triangle there, so this is easy. 2, which is the square root of 3. Okay? So that's coming back. In fact, if Justin might have had a little bit of experience going back and forth between these, actually. Well, in IB we do that, and in math team we do that.
We learned the other ones too, like the spirit coordinates.
Just the polars. Okay, and polar graphs actually are the graph paper is circles. It doesn't look like the XY plane at all.
They're so weird.
Yeah, pardon?
That's so simple.
But that's how airplanes fly. They don't use Cartesians.
Can we get some?
Polar graph paper? Sure.
Buy it.
I know, I heard that already today. Okay, this is X and this is Y. I want to find R and theta. Okay, how are you going to do that? Just these batteries. Tangent of theta is equal to y over x, right? So the tangent of theta is equal to -1 over 1. So theta is equal to the inverse tangent of that. What angle is that? Matt? It's the, let's graph the point. It's 1 And it's -1, because they gotta be the same. No?
45 degrees.
Negative
pi.
Negative 45 degrees, because remember, we restricted our inverse tangent to be first or second quadrant. So theta is equal to -pi/4. If I draw the picture, it's a lot easier to see this, and I want to know what the radius is. And remember that what? X squared plus y squared equals r squared. So it's 1 squared plus 1 squared, actually -1, but same difference, equals r squared. So r squared equals 2, r equals square root of 2. Could I just use simple geometry? Yes, because this is 1, that's 1, and that's square root of 2. So the ordered pair is square root of 2, -pi/4. It's just a different way of thinking. Mm-mm.
I can't.
How could you write this point a different way? Same point though,
You could do negative square root of
2.
comma pi, 3 pi over 4.
Yeah.
Oh!
3 pi over 4? Okay, so 3 pi over 4 is 1, 2, 1, 2, 3, and -2 would go that way, yeah.
I don't trick you.
Could you have, stop saying 4, there's a lot of ways you can do it.
7 pi over 4.
Okay, we got it.
Yep,
Oh,
okay. Now for the fun stuff. This is the graphing. This is very different than what you have done before. The radius is always 2. I want to graph that in the x. It's a circle.
This is comfortable.
The radius, it's just a matter of thinking like this, is going to be 2. I want all the points where the radius is 2. And isn't that a nice way to write the equation of a circle? As opposed to x squared plus y squared equals what?
that's a lot.
4. That's why we have polars, because a lot of times it's easier to represent something in polars than it is in Cartesian.
You're gonna make that.
It could.
Yeah, that'd be nice.
Pardon? Yes, we'll make flowers today. Okay,
We can make flowers.
all right, with our graphing calculators. Okay, but first we have to learn how to plot these things. Okay, shh. I want to graph so that my angle is always equal to 1. The angle is equal to 1. How many, now these are always in radians, how many degrees? About? No, bigger.
That'll be like 40, no, it'll be more
No.
than 45, that's like 90.
Why do they use radians? Why not just
60.
Because they're arbitrary. Why would we divide a circle into 360 equal parts?
Be like 65.
It's because somebody did it.
65.
It's about 60 degrees. So, theta is 60 degrees. About.
Why don't you draw a line?
Because it's a line, right?
Oh, no, why do you draw it down?
Because I'm trying to get you to realize my angle is always equal to 1. So this is how you write the equation of a line.
Wow.
Whoa.
Do we have to get like specific with that? Sound like we like, we actually have to,
Well, you should know it's about 60 degrees.
we have to actually say we have to find out the exact.
Yeah.
No, that would be all you did. They're not going to do anything as simple.
Could you explain that?
The angle, the radius is anything. Any number. So if the radius is 1, I'm going to go at an angle of 1 radian, which is about 60 degrees. So there's 1. If r is 2, then I'd have this point. If r is 3, I'd have this point. But r could be a half. So the only thing is, r can change, but the angle can't.
So the graph of x would be 1 and the pi over 4?
What do you, the graph of y equals x?
Yeah.
Yes, you'd have actually have pi's in there.
And then this little, like, little curved line.
That's just my angles. Those are just my angles. That's all. Do you know why radian is 60 degrees about? A radian, not quite, a radian this is the radius. You take the arc length so that it's equal to the radius. That's a radian. It isn't 60 degrees. It's a little bit smaller. And that's why when you do this, 180 degrees, it's not going to be 60, 60, 60. How many of these can you put in a circle? This is a little more than 3 to get to the 180. That's what's 3.14. And this is 2 of that times 3.14, 6.28. So 6 times 60 gives you 360, which is a little short because it's about 57 degrees. I know, that's why I thought I should talk about this. It's kind of cool. If you measure it out, you can do that actually in pre-calc. I had the students do that. Take a piece of string, measure that.
So we're not here right now.
Marcus, are you ever here?
Oh,
Okay, now for the hard part. We're not going to use our calculators. We're going to do this by hand.
We're gonna ask that after this.
This next graph is one you have to know.
Hey,
What's the student average in class? You got the lowest possible score.
Is it later than that?
What if I beat you on stats?
Okay, guys. Shh. Okay, guys. We're going to graph this one by hand. This is the one you have to know on the exam. So, I'm going to take different values of theta and find the radius that goes with it. So if theta is 0, I'm going to use my little chart here. Let's do pi over 6. Let's do pi over 4, because I know these without a calculator. Let's do pi over 3. Pi over 2. You'll see what's going to happen. 3 pi over 2. Well, I don't know the cosine of like 2 radians. I know what the cosine of pi over 6 radians is.
I don't know, why can't you do minus?
Oh, let's put pi in there? Okay, I don't know why it's not on my, I missed it. Sorry, missed it. Okay, so the radius, now, when when theta equals 0, the radius is 2 times the cosine of 0. So let me get my graph, and we'll plot that. Do you guys know what this is going to be? So we're going to start here at 2. Okay, ready? What about pi over 6? So when theta is equal to pi over 6, r is equal to 2 times the cosine of pi over 6. That's 30 degrees. So should I draw my triangle? 2, 1, square root of 3. This is pi over, this is 30, this is pi over 6. So it's the square root of 3 over 2. So this is approximately square root of 3, which is about how big?
Approximately 1.2.
Less than 2. 1.75? Yeah, actually it's about 1.7.
Well, I completely guessed.
You completely guessed right. How about pi over 4? Okay, so this is going to be 2 times the cosine of pi over 4, which is 2 times, well, okay, you've memorized that one? Okay, and this is why it actually works out nicely to have it rationalized, if I don't have a calculator. Do you guys know how big that is?
1.4.
1.4. It's close enough, we can't get better. Okay, so as we go around, the cosine of pi over 4 is square root of 2 over 2.
Rationalize.
Otherwise, you're going to get 2 times 1 over the square root of 2, and then you're still going to have to rationalize, or else you're going to have to use a calculator.
I did not remember that at all.
Okay, so at pi over 6, 30 degrees, I'm going to be at 1.7. That's a little bit short of the 2. At 45 degrees, I'm going to be at 1.4. So here's 2. Here's 1. I got to be up here someplace. I want to get it to be nice. Oops. I was just going to move that. Then I guess. Let's get that out of there.
need a ellipse.
Yeah, what do you think? Okay, well, let's keep going. What about pi over 3? This is 2 times the cosine of pi over 3. Where is this? Not negative 1. 1. So at pi over 3, which is 60 degrees, I'm going to be at 1. Okay, I'm sorry, my picture's not great. What about pi over 2?
Oh, that's 0.
That's 0. So now I'm going to be here. If I try to connect the dots as best I can, in the order, the directions that way, what about at pi?
I guess it's going to do the same thing.
It's going to be, at pi, it's going to be 2 times the cosine of pi, okay, which is a negative 2. So I'm going to go over my pi angle, but I'm going to go back what? This is my ray. I'm going to go back 2. Guess what where I'm at? Same place.
It's going to bounce.
So what's going to happen down here? No? Should we try one? Should we try, let's see, pi over 2. Should we try 3 pi over 4? 3 pi over 4 is 2 times. Now, let's see, cosine in the second quadrant is still, is negative, right? Okay, so this is going to be square root of 2 over 2, but it's negative. So it's negative 1.4. So if I go this 3 pi over 4, I got to make sure we get this right, is this way. If it was a positive radius, I'd be out here, but it's a negative, so I'm going to go right here.
Circle.
Do you understand why it was so important to talk about plotting the points? Because I don't know how to plot the points to do this. You're right, it's going to be a circle here. Sorry, my picture's not great, but that's what it is. So, if it is r equals 2 cosine theta, it's going to be a circle on the x-axis. The radius is not going to be 2. It's going to be 1.
Are we not going to run it?
Oh no, we're not done yet.
Oh,
Whoa there. But
What if I have r equals 2 sine of theta? Where do you think that one is?
Give me on the other side, I guess.
Well, let's do theta equal to 0. What's the sine of 0? 0. So then should we do pi over 4? Theta equal to pi over 4 is equal to 2. R is equal to 2 times the square root of 2 over 2. Okay, it's about 1.4. So at pi over 4, it's going to be at 1.4. It's going to be here. What about at pi over 2?
Is it the same circle that's going the other direction?
No, it started here. It's going around like, because what is the sine of pi over 2? You might have. Sine of pi over 2 is 1.
We definitely did it.
Yeah.
Oh, okay. And it keeps going around like this. Okay, you guys, you have to know what these two graphs look like on the non-calculator section. They could easily ask. And nobody tells me what was on last year, so I don't know.
Why wouldn't this just look like
Because it's not a regular sine curve. It's the distance from the origin is going to be a function of whatever angle you're measuring at times a number. So it's, it's counterintuitive. So maybe we'll cheat a little bit and use our graphing calculators to do the next one, which we'll have to change to polars. So, this little guy.
You go back.
I'm going to bring up my calculator. You guys have your calculators?
Come on.
You know, I haven't done this on the Inspire.
Let's do it after we do it on 85.
84.
84.
Pardon? I don't know. I haven't tried it.
So for r equals 2 sine of angle, it's just a circle that's on the x-axis.
Let's do this one, but I got to go change the mode, and I want to go to polars. Well, you can play with it. Press enter. It should we. And now make sure your mode is in radian mode. Okay, Kevin?
That's a question.
And so, yes?
For the trig, we have to go with the radius
Yes, but you have to know anything times cosine theta.
You know, but I'm just saying, just in general terms, that was on multiple choice.
Look at that, I'm gonna get a theta. So the radius is as a function of theta. And we're gonna zoom it, let's try decimal and see if that works. There it is.
Oh, look at that.
Now, it's got angles to it, and it should be a circle. So I'm going to press window, and I have 0 to 2 pi. Let's make our step smaller. So if I make my step bigger, do you want to play with this? Let's make this, not 2 pi, let's make it 4 pi. Can't see it, is that it? Okay, and let's make the step size bigger. Let's make it 1.
Whoa. Whoa. Everybody, whoa.
How'd you press that?
In your window,
Hold on.
I've changed this to 4 pi.
What's your y-axis?
R is 2 cosine theta.
4 pi. And what about step?
I stepped at 1. I could step at 2. It's not going to be quite as interesting, I don't think.
Oh!
Right, because it's doing 2 radians and plotting a point, not teeny tiny things.
So you don't get
So if I want, no, you don't get a very good picture. So if I really want to see a good picture of it, I want to do 0.01. I like to see it go slower. Okay, it might be a little slow. I just zoomed at decimal, so I get nice numbers. And notice it's still thinking, how many times will it go around?
We need your.
I made it 4 pi. 8. I believe it'll be 8.
Wow, darn, my calculator's getting stuck on this.
Oh, how do I get out of it? Press on.
Second click.
Never
Yeah,
works. you're right. Yeah, no.
Never works.
Second.
It's just did.
Second.
On usually breaks it. Okay, so then if I go in here and I put in 2 sine theta, sometimes I ask you to find where these intersect. It's not that hard. If you think about it. You gotta think about it. That's why I said it's a different way of thinking. And then let's change this so I'm not doing 4 pi. Let's just do 2 pi. 2 second pi, so we don't have to wait forever. And 0.01. I'd like to have it that small so I have a nice smooth curve. Before when I did it, I didn't have a smooth curve. Okay, this is 2 pi. So this is pi right there. It's going to continue going.
If you do normal pi, it's what triangle?
Sick.
It's a triangle.
Yeah,
No, if I just go to 0 to pi, it's going to be the circle.
I got a triangle.
You have to change your step size to small.
What's it doing now?
This doing the other graph, that's the 2 sine of theta. How do I remember? Because I know that x is the cosine of theta. So when I get the cosine of theta, it's going to hit the x-axis. It's going to be centered on this x-axis. Yeah.
Just do it.
Well, you guys can do it.
That is very
Okay.
Wait, Mr. G, what is changing the window?
Let's, changing the window just changes one part of the window.
Can we make a flower?
Yeah, let's do this one. This is an interesting one. It's a very famous one. And we can make flowers. We will. We'll clear that. And as you guys play with it, you'll figure out how to do that. You should think about y. This is 1 plus r, 1 plus sine theta, right? Is that all it is?
R equals 1 plus. It's gonna be the circle sitting above the x-axis.
Well, that's what you would think, isn't it?
This is
But it isn't. It's a cardioid. It looks like a heart.
What do we have to do with these, Mr. G? Or could we just do it on our calculator?
These you can do on your calculator.
Five.
Come on, come on. There it goes.
Says,
What is this famous for?
This is a cardioid. Looks like a heart.
That.
Well, because it's not a very good picture. It looks like this.
Should I zoom in?
I don't know if that'll help.
Okay. This step needs to be a
It looks more like a brain.
well, did I actually do it at the bottom of it?
Right? Yeah, it does that loop-de-loop. Okay, should we do some flowers? That's the next one. Now, only assignment, I don't have any AP stuff in there. Unless we continue to go on and do what we can with polars today. We don't have much time. R is equal to the cosine of 2 theta. So this one, we will use our calculator, but you could figure this out. What does I say, the cosine of 2 theta?
Oh, look at that.
Whoa.
I could change my step size to be a little bit
Whoa,
bigger.
whoa, whoa, whoa! It's like a,
Look at that.
it's like a flower.
No, it's like a new
Now that was the cosine of 2 theta. What if we did 3 theta?
Cactus flower. No, 4-leaf clover.
Did you know those?
So I'm going to change my step size to be a little bit bigger because that's too slow. And then I'll make that 3 theta. I get 3. What if I do 4? So you could draw some. I'm just zooming in a decimal window.
How many steps did I go to?
Oh, I gotta do smaller than that. That's not good. Okay, I also don't like my window. Let's try square. That's not any better, is it? And then we're gonna have to change the step size to 0.01 again. Or 0.1. Let's try 0.1. I had it too big. There we go. How many petals?
What is this size do?
It's how often the points get plotted.
Kind of like how accurate it is.
4.
It's like a atom.
Yeah.
It's like an atom.
Isn't it for the atoms?
Well, let's find out. Let's do 5. I don't know.
Yeah, I don't think that's fine.
This is why graphing calculator is next.
It's a starfish.
No, it isn't. I don't know if it's 5. I don't know if it's just 5. What? I'm going to change this to 1 and it won't be square, okay?
I thought it said 30 this whole time. I was like, wow.
I missed you, son. We can use calculator.
There's a much better one.
Missed you.
It's like
So what do we do with these? When do we just grab them?
Well, if you do the assignment, and the assignment is a guide to make sure that you know what you're doing. It's not time to go yet. It's 11:58. No, it's on this. Now we can start day 2 if you want today, and then we'll finish with 1. Okay. You need to be working on. Where do you guys go? We got 5 minutes left. Working on AP problems. Do you have any AP questions for me?
I have a question. For polar day 2, what do we learn that is not the same as
We're going to find out how to find derivatives and find areas. That's the important stuff. That's the calc stuff.
Dang. So that's
You have to set up the areas.
Well, it's like
Hey, give me a shout out.
Only if you have a class.
there.
What if you want to find a derivative someplace else?
Yeah, no,
So it's complicated tomorrow.
it'll be on school sheet tomorrow.
Yes. Let's do 6 theta.
And then for the chapter test,
Oh, look at that. Now we could have to design a shirt with all these pretty patterns.
so for the test, the chapter 6,
What did he say?
Guess what shirt I brought from on it today?
Your new substitution shirt? Yeah.
Okay, so for the test next week, it's all chapter 6.
And
Okay.
polars and vectors. Now you guys, we've done vectors. Guys, it is not time to go. Have a seat. You guys can work on some AP problems. Do you want to do them together?
Like, chapter 6 is at 6.